Pleasant day to you, everyone. Today, I will be discussing the complex systems for control of blood flow. Now, we have uh, three complex systems for control of blood flow. First, we have the local control of circulation. A fundamental principle of circulatory function is the ability of most tissues to control their own local blood flow. Local control of circulation has specific needs for the body's tissues for blood flow. First is the delivery of oxygen to the tissues. Next is delivery of other nutrients such as glucose, amino acids, and fatty acids. Third is the removal of carbon dioxide from tissues. Then the removal of hydrogen ions from tissues. Fifth is the maintenance of proper concentrations of ions in the tissues. And lastly, the transport of various hormones and other substances to different tissues in the body. Local control of circulation is divided into two phases. First, we have acute control, which is achieved via rapid changes in local vasodilation or vasoconstriction of the arterioles, metarterioles, and precapillary sphincters that occur within seconds to minutes to provide immediate response to the maintenance of appropriate local tissue blood flow. Second is long-term control, which refers to slow, controlled changes in flow over a period of days, weeks, or even months. In general, long-term control provides an even better control of the flow in proportion to the needs of the body's tissues. Now, local control of circulation has its importance. First is that the workload on the heart is kept to a minimum. This is due to the blood flow to each tissue is regulated at the minimal level that will supply the tissue's requirements, no more, no less. Second is that controlled local blood flow keeps the body's tissues from experiencing oxygen nutritional deficiency, since circulation of blood is regulated at the minimal level or exact level that will supply bodily tissues needs. Next we have is humoral control mechanisms. These function to control pressure through vasodilation and vasoconstriction, as well as alteration of blood volume. Humoral control refers to the control of circulation by substances secreted or absorbed into bodily fluids, such as hormones. Some of the substances secreted or absorbed are formed due to special glands and transported in the blood all throughout the body. Others may be formed in local tissue areas and only cause local circulatory effects as well. Now, there are humoral factors that affect circulatory function. First, we have vasoconstrictor agents such as norepinephrine and epinephrine. Second, we have vasodilator agents such as bradykinin and histamine. Third is the vascular control by ions and other chemical factors. Many different ions and other chemical factors can dilate or constrict local blood vessels. An example is an increase in intracellular calcium ion concentration, which causes vasoconstriction due to the general effect of calcium to stimulate contraction of smooth muscles. Lastly, we have nervous control, which has more global functions such as redistribution of blood flow to different areas of the body, increment or decrement of pumping activity in the heart, and providing immediate control of systematic arterial pressure. The nervous system controls almost the entirety of circulation through the autonomic nervous system. In charge of the body's circulation is the sympathetic nervous system. On the other hand, the parasympathetic nervous system contributes to the regulation of functions in the heart. Now, in summary, the local, nervous, and humoral control of blood pressure is an integrated physiological response that maintains the essential homeostasis of blood flow to tissues. Local, nervous, and humoral control of blood pressure can work independently of each other, but there are also interactions among them. Local control of blood circulation is intrinsic to various tissues in the body and operates independently. Humoral control of blood circulation relies on substances secreted or absorbed into the body that help in the initiation of vasoconstriction and vasodilation. Lastly, the neural or nervous control of blood circulation involves the central nervous system and relies primarily on the release of norepinephrine from the sympathetic nerve endings of the autonomic nervous system. That is all for the complex system for control of blood flow. Thank you.